All right, everybody, this is 8.4, our last lesson for this unit. We're doing piecewise functions again, part 2. But last lesson, what we did is we were able to write down our equations from a graph. Now we're going to be able to write or fill in our graph given our equation. All right, so just a quick reminder on how to graph each of these types of functions. So the first one is a quadratic in vertex form. So we can easily find our vertex. So -1, -3, -1, -3, and then we'll use our growth pattern. A here is 1, so we'll do 1. And the growth pattern is 1 times A, 3 times A, and 5 times A. Continues 7A, 9A. So here if A is 1, we'll go over 1, up 1, over 1, up 3, over 1, up 5 on both sides. Okay, so you're going to do this very similar when we do, oops, I messed that up, didn't I? Very similarly when we do the piecewise functions, it's just that your graph may start and end at certain parts. All right, here's an absolute value function. Looks like we have a vertex of 3, 2. And the slope is -1/2, so down 1 over 2, down 1 over 2. So rise over run. And then we mirror it to the opposite side. Okay, and again, you'll probably have some sort of domain restrictions where maybe it will only go between, I don't know, like from here to here or something like that. Okay, and then last is a linear equation. Again, this is your y-intercept. So it would start here, and then our slope would be 2 over 1. And then we'll just connect our dots. And again, you'll probably have some sort of domain that applies to that. Okay, so graphing these, what I would recommend is that you would draw dotted lines for each piece of the domain. Okay, after that, then we can graph each of the equations, but we need to make sure we keep them in the domain that it belongs. Okay, and then we also want to check the ends. So whether it's going to be filled in or whole. Okay, so let's just go into this problem. So first off, our domain for the first equation is between -3 and 2. So here I would maybe draw little dotted lines. Maybe I'll do purple this time. So -3. Okay, and then it goes all the way to 2. So this equation that we have, like y equals, and maybe I should have this be f of x. So this equation only applies, or y equals 6, but that only applies between those two lines. So this would look like this. The horizontal line has a y-intercept of 6 and a slope of 0. Okay, all right, the next one, this graph goes from 2 to 8. So we already have the dotted line for 2, and then 8 would be here. Okay, and we want to graph that equation. So this is a linear equation. So again, that tells us our y-intercept is -3. But hang on, this isn't in the right domain. So either you can draw it and then erase it later, or you can kind of think, let's draw it and then we'll erase it. So then our slope here is down 1 over 2. Okay, but we only draw it between that domain. So we only want to draw that line there. Okay, and maybe we'd even want to erase that y-intercept. Otherwise, that might be a little confusing. Okay, all right, now we need to look at the endpoints. So this is telling us that it includes -3, so we'd fill that all in, where this tells us that it doesn't include. So this would be like an open hole. For the 2, for the other equation, that includes it, so we'll have a filled in dot. And for 8, it's open, okay? And now we're all good. That's all we really need to do. We have our piecewise graph. Okay, why don't you pause and give this one a try. So here we have one domain line. It is only at -1. So we'll do this dotted line here. So the first equation only applies when x is less than or equal to -1. So this equation only applies here. And then the other equation, this only applies on the right side. That only applies when x is greater than -1. So we'll still do our first equation first. So this would be vertex would be -2, 1. -2, 1, which is right there. And then we'll use our growth pattern. So a is 1, we'll go over 1, up 1. But we just ran into that line, so we'll just go the opposite side. Over 1, up 1, over 1, up 3. And then we'll connect our dots. Put an arrow there. Let's look at the domain line. It's x is less than or equal to -1, so we'll have this be filled in. Please make it exaggerated so that I can make sure that I understand what you're doing. So that is a filled in one. Our other equation is a linear. The y-intercept is 4, so we have a point here. And then it has a rise over run of 1. So up 1 over 1, up 1 over 1. Connect those dots. And here it doesn't include, x is greater than but not equal to -1. So we'd want to make this be open. Again, you might want to erase some stuff to make sure that it's visible to show that that's open. Okay, so I think there's maybe 2 more examples if we want to go over, and then these last 2 are really quick, and we'll talk about those 2. So pause and give this a try if you would. Again, we'll start by drawing our domain lines. We have one at -4, and we have one at 1. Okay, this first equation applies between -4 and 1, and this equation applies when x is greater than 1. So we'd put that equation there. All right, so let's draw our lines. This is our vertex, -3, 1. So -3, 1. And then the slope, again, this is an absolute value, so it's going to look like a V. This would be a rise over run, so we go down 2 over 1, down 2 over 1. And we keep going until we hit our domain line. And then we'll mirror it to the opposite side. Let's look at the end behavior. So here at -4, it's not included. So we'd want to have a nice big open circle. And then here, that does include it. So we'll exaggerate and make that be a little bigger and filled in. Our other equation is a quadratic. So the vertex would be 2, 0. 2, 0. And it has an a of 1, so we'll go 1, 3, 5. So 1, 3, 5 would be out of our graph. Okay, and then when you look at the end behavior, so when x is 1, it's not included, so this would need to be open. All right, and I think that's it. All right, last but not least, another domain line at 3 this time. So we have this dotted line, okay. This is our first equation. It's when x is less than 3, so it's on this side, and this equation will be on this side. So this is a quadratic. Again, this is like in vertex form. This would be our vertex, so -3, 0. -3, 0. And it has a is 1, so it's going to go 1, 3, 5 would be out of our graph. Okay, this was probably not a great great example because you're not going to be able to see the end points. Okay, but if we did, this would continue lots of ways, and then eventually it would be open. Okay, so sorry about that. I probably need to fix that. Maybe I'm not sure what I was trying to do here. But anyways, the other one is an absolute value function with the vertex is 2, -4. So 2, -4. Oh, but that's not in the right domain. And the rise over run is 2 over 1. So it's going to do something like this. Maybe we won't even do this in our class. Okay, and it includes that point, so we'll have that filled in at 3. Okay, maybe erase that because that's not in the right domain. All right, okay, last thing we need to do is just sketch a piecewise graph that would model this situation. So how about we do this one together and you can try B by yourself. So it says John's taking his dog for a walk. So he's walking. This is maybe going to say like distance from home, and this is maybe time. So he takes his dog for a walk. Maybe he's going at a constant rate, but then he has to stop and tie his shoe. So when that happens, the time keeps going, but his distance isn't changing. And then he starts walking again. So that would be like an example of a piecewise graph that could model this situation. All right, give this one a try. So Joe is cliff jumping. He jumps off of a rock, so maybe he starts up here. When things fall through the air, it usually is a quadratic, so it's going to come down something like this. All right, once it says he jumps from a rock, once he comes up for air, so he's going to go into the water somehow, and then he walks to shore. So he swims. Okay, so maybe that line continues to go that direction. So again, it's not like specific. If you drew it a little different, that's probably okay as long as it kind of applies to the situation. All right, and then vice versa, being able to come up with some examples that can model a piecewise graph. So here, there's lots of ways you could do this. For A, maybe we could just talk about a couple. It could be an airplane that takes off, reaches its max altitude, and comes and lands. Okay, that could be an option. Another could be like an oven. You preheat the oven. You cook something for a while. You turn off the oven and it goes down. You could walk to a park and you sit for a while and then you walk back home. So lots of different things that you could write. Why don't you give B a try? I'll leave that one out for you. This could be very kind of similar to what we did above. Something that's being projected throughout the air and then comes down and lands and then maybe rolls or something until it and stops on the grass or something. I don't know. So something like that could be possible. Okay. All right. Let me know if you have any questions. We'll see you later.